Hi, welcome to PID Maxwell YouTube channel. In this video, we're going to demonstrate the control effect and control accuracy of our PID controller MAU90 series. So this is the controller we're going to discuss today. So basically it comes with several options on the size. You can choose 48 by 48, 48 by 96, 72 by 72, and 96 by 96, as well as the horizontal configuration, which is 96 by 48. So this controller supports universal inputs, works with thermocouple, RTD, and analog inputs like 4 to 20 milliamps and 0 to 10 volts. You don't have to specify the input while order this controller. It just comes as standard package to work with all kinds of inputs. The output can be SSR drive, relay, 4 to 20 milliamps, 0 to 10 amps, as well as some of other not very popular output like track output, phase angle output, etc. You can reach out to us for more information. The accuracy of this controller is 0.25%, which is pretty high accuracy. And the sampling rate of this controller is 250 milliseconds of sampling rate, which is 4 times per second. This sampling rate is enough for not only the temperature control, it also capable of control the other process like pressure, for example. And the biggest advantage of our controller is that we offer 36 months of warranty, which is 3 years of warranty against of the manufacturing defective. So if anything happens within 36 months, we gave you the replacement. So I have a small testing kit setting up here on the desk. This is the controller itself. Over here we have a single phase SCR power regulator, which is controlled by 4 to 20 milliamp inputs, and the analog signal is coming from the controller. And over here we have a incandescent lamp, light bulb, which generates heat and light after power on. So as I said in the beginning of the video, we're going to demonstrate the control effect. To have an accurate control effect, you have to execute the auto tuning first. So before active auto tuning, you need to set up your controller in the field aggregation with everything wired up correctly. The heater, the SCR power regulator, or solid state relay, or AC contractor, whatever works for your system, and the controller. Everything needs to wire up 100% correct. So we are going to we are going to execute the auto tuning at 80 degrees. So first thing would be set to configure the setting value at 80 degrees. There you go, set the setting value as 80 degrees and run the controller. And then engage the auto tuning simply by press the left arrow button. You can see the auto tune. Now it's off. You can change to on to turn the auto tuning on. now the auto tuning has been engaged successfully. The upper display will show the process value, and the lower display will show the target value for auto tuning and AT, simultaneously, kind of flash between the setting value and AT. So the auto tuning is going to take a little while, probably, and the time duration of the auto tuning really depends on your application. It takes some time, takes different time, depends on different application. So the auto tuning is a completely automatic process. Just be patient and do not intervene during the entire process. The auto tune will finish by itself. And the auto tune is a on-off process. There will be some overshoot during the auto tune process. Don't worry about it. It's quite normal to see some overshoot. Now the auto tuning process finished. The setting value is 70 degrees. Right after the auto tuning finished, the controller will go into the normal working mode and try to maintain the temperature at the setting value. It takes a little while for the controller to level up to reach the setting value. Well, let's wait and see what happens. You can see the temperature slowly going up to 70. It's going to take a little while, but it's going to get there eventually. There you go. We have 68.9, 69. Now we're close. One thing I do want to emphasize is a light bulb in the open space is pretty hard to control because the heat generate pretty fast and dissipate pretty fast, because the light bulb is placed in an open space like this on a table, so the heat will be generated pretty quickly, and if something happens, the heat goes away pretty quickly. If a controller can control a light bulb accurate, means the ability in terms of the control accuracy is good. Now you can see the temperature level up at 70. It's very accurate with 1 decimal point. I'm going to let it run for another 1 minute and change the setting value to 60, 40, 30 and see how it goes. Okay, 70, 70.3, 70.2. I'm going to let it run for another 30 seconds. And then we're going to change the setting value to 80 and see how it goes. Okay, I think we're pretty good. Let's go to 80. You can see the temperature slowly ramp up towards 80 degrees. Now it's 75.8. 76.9, 77. Okay, I think we're pretty good. 79.3, and we're pretty close to 80. Okay, 79, 80. Okay. Now the temperature stays at 80, exactly the same as the setting value. Just a little fluctuation, 0.1, 0.2. Okay, let's change the setting value back to something lower, like 50, and see how it responds. you go. There we go. We changed the setting value from 80 to 50. As you can see, there's no overshoot at both 70 and 80 degrees. It's going to take some time for the temperature to go back to drop to 50. Okay, we're getting close to 50. Now you can see there's an input, there's an increase on the output, right? The output is from 0% to 100%. It's constantly changing according to the PID algorithm. Okay, excellent, excellent. 51, 50.8. We're gonna wait until the PV levels up and equals to 50. Okay, now the process value is equals to the setting value. Okay, 49.87. There's a little fluctuation, like 0.5 degree, and I'm pretty sure it's gonna come back to, yes, 49.8.9. Just to let you know, it's impossible for the process value to stay at one fixed value all the time, because the control or any application on the field is a dynamic process. It keeps changing. The wind blows, the ambient temperature, the other interference. So it's not possible for the PV to stay exactly the same as the SV all the time. Nothing changes. The actual process doesn't work that way. So there's going to be always a little fluctuation, as long as the fluctuation is within the acceptable range. I'm sure, you know, customer or the end user should accept that. Okay, we're back again to 50. It's a self-learning process for the controller too. Okay, I think we're pretty convinced that this controller is capable of handling high precision control. Please contact our sales team or technical support team for more information if you want to know more about this product.